Dear students, in your board exams, in the last part, the last question, the 5-marker question, will be a descriptive one, a lengthy one, a essay type one. And you can expect a theorem there. And how do they ask you the question? State and prove Pythagoras theorem, or state and prove the Thales theorem. Today we are going to prove the Pythagoras theorem. Pythagoras was a Greek philosopher. Approximately his time was between 500 BC and 475 BC. He is referred to as the first pure mathematician. He was very well educated, knew poetry, and was interested in mathematics, philosophy, astronomy, and music. He had started a school called the Semicircle. There are around 400 different proofs for the Pythagoras theorem. Here, for your level, we are using the similar triangles to prove the Pythagoras theorem. What is the statement of the Pythagoras theorem? What does it state? In any right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides containing the right angle. I have triangle ABC. Angle A is 90 degrees. The side opposite to angle A, that is BC, that becomes the hypotenuse. And you should also know that in a right angled triangle, the hypotenuse will be the longest side. So, what is that they have given us? The data. The data is they have given us triangle ABC. Angle B is 90 degrees. And what is that we need to prove? We need to prove that the square on the hypotenuse, BC square, is equal to the sum of the squares on the other two sides. The other two sides are AB and AC. The squares on AB and AC are AB square and AC square. The sum will be AB square plus AC square. So, the square on the hypotenuse is equal to sum of the squares on the other two sides containing the right angle. For that, we have a small construction, and the construction is from the right angled vertex. The right angle is at A. From the right angled vertex, draw a perpendicular to the hypotenuse. Draw AD perpendicular to BC. Now the proof. After I have drawn the perpendicular from the right angled vertex to the hypotenuse, within this original big triangle, which is a right angled triangle, I have got two smaller right angled triangles because AD is perpendicular to BC. This is ABD, the first right angled triangle. ADC will be the second right angled triangle which I have got in this bigger right angled triangle. If I can imagine this figure to be a small puzzle like thing, and as a smart board, if I am able to drag this triangle ABD outside and place it here, I have dragged that small triangle ABD outside. Angle D will be the right angle. And I am dragging this bigger triangle ABC and placing it here. Now, in triangles ABC and ABD, in these two triangles ABC and ABD, angle A of the first triangle is equal to angle D of the second triangle. Both are equal to 90. Angle A was 90, which was given to us in the data. Angle D is 90 because this was the construction that we did. If you drag the smaller triangle into the bigger one, into the original one, you can see that angle B will be common in both the triangles. So angle B of triangle ABC and angle B of triangle ABD both will be common. In two triangles, if two pairs of angles are equal, the third pair will automatically be equal. So angle C of the first triangle will be equal to angle A of the second triangle. The third pair of angles automatically will be equal. Therefore, triangle ABC and triangle ABD are equiangular. If they are equiangular, then they are similar. They are similar means then their corresponding sides are proportional. So this is a flow. If in two triangles the three angles of the first are equal to the three angles of the second, then the two triangles are said to be equiangular. If the two triangles are equiangular, they are similar. If they are similar, then the corresponding sides are proportional. What are corresponding sides? Corresponding sides are the sides which are opposite to the equal angles. Therefore, the corresponding sides will be, I will take the first pair of equal angles, angle A and angle D. Angle A is here and angle D is here. The side opposite to angle A is BC divided by the side opposite to angle D is AB. So I have got the first pair of corresponding sides, that is equal to, take the second pair of equal angles, angle B in the first triangle, it is here, side opposite to that is AC divided by angle B of the second triangle is here, side opposite to that is AD. That is equal to, come to the third pair of angles which are equal. Angle C is equal to angle A. Where is angle C? Locate angle C. It is here. Side opposite to that is AB divided by angle C is equal to angle A of the second triangle. Angle A of the second triangle is here. The side opposite to that is BD. So I have got three fractions here, and in these three fractions you can find one denominator of one of the fractions and one numerator of another fraction to be the same. Let me equate those two. The other one is not necessary for our proof. Therefore, BC by AB will be equal to AB by BD. Now if I cross multiply, AB into AB is AB square, that is equal to BC into BD. BC into BD. This I will take it as equation number 1. Now if you go back to the figure, I have found out the square of AB. I will now find out the square of AC. After finding out the square of AC, I'll add AB square and AC square. Let me find out what answer I will get. Equation 1 is AB square is equal to BC into BD. Now I will try to find out what is the value of AC square. So for that, I will drag the original triangle ABC, and then the second right angled triangle which we have got after drawing the perpendicular ADC, I am dragging it and placing it separately. This is for you to understand the proof well. Now in triangles ABC and ADC, angle A of the first triangle is equal to angle D of the second triangle. Both are equal to 90. This angle A is 90, which is given to us. Angle D is 90. This is by construction. Now again, I'll retrace what I told you in the first part of the proof. If this second triangle, which is the reference figure which is drawn, if it is dragged and placed in the original triangle, we can see that angle C will be common. So angle C of the first triangle and angle C of the second triangle, they are common and naturally they'll be equal. So in these two triangles, two pairs of angles are equal. Therefore, the third pair automatically becomes equal. Therefore, angle B is equal to angle A. Therefore, triangle ABC and triangle ADC are equiangular. If they are equiangular, then what will be the next step? Therefore, they are similar. And if they are similar, the next step will be, therefore, the corresponding sides are proportional. What are corresponding sides? The sides opposite to the equal angles. Now, we'll take the first pair of angles. Angle A of the first triangle. Side opposite to that is BC divided by angle A is equal to angle D of the second triangle. Side opposite to angle D is AC equal to second pair of angles. Angle C of the first triangle. Side opposite to that is AB divided by angle C of the second triangle. Side opposite to that is AD. That is equal to the third pair of angles. Angle B of the first triangle. Side opposite to that is AC by angle B is equal to angle A of the first triangle. Side opposite to that is DC. Again, if you see the three fractions that we have, one of the denominators of one of the fractions is equal to a numerator of another fraction. We will equate those two. So I have BC by AC is equal to AC by DC. Therefore, by cross multiplying, AC into AC, AC square is equal to BC into DC. This is equation number 2. So I have found out the value of AB square, and that is the first equation, and I have found out the value of AC square. I will add AB square and AC square, meaning to say I'll add the first equation and second equation. If I add the first equation and second equation, the left hand sides are added, the right hand sides are added. So what will I get? AB square plus AC square, the left hand sides of the two equations, is equal to the right hand side BC into BD, the right hand side of the first equation, plus right hand side of the second equation BC into DC. And in the right hand side you have BC as a common factor. Remove it outside. If you remove BC as a common factor, what is left? BD plus DC is left. That is equal to BC into, if you see the figure, the original figure, if you add BD and DC, you will get BC. So BD plus DC is nothing but BC. BC into BC is BC square. Therefore, AB square plus AC square is equal to BC square, and that is what we were supposed to prove. The square on the hypotenuse is equal to the sum of the squares on the other two sides containing the right angle, and that is the proof, and hence proved.